open up a new Colab notebook, colab.research.google.com, click on the new notebook option, and then we're going to go ahead and open up on the sidebar here, scroll down to this folder option, and click on that. It's going to connect to a runtime, and then we're going to look at some of the sample data, in particular the MNIST dataset. Okay, it says MNIST train small. Go ahead and copy that path by clicking on the three dots, select copy path. Go over to your Colab coding cell and let's try data train, and then put that path in quotations. And similarly, let's do the same thing for data test. Now, you may be wondering, what is the MNIST? Well, this is a very famous data set, and you can look online and you can see it's the Modified National Institute of Standards and Technology database. It's numbers, right? It's handwritten digits that have been stored here. Okay, so you can see here is a sample of them. So the idea here is that there's a machine learning project which is very famous historically, which is to classify these digits, but note that they are images, right? So that data set is actually provided for you with Colab. Let's take a look at it. So go ahead and import pandas, and you can see it's a CSV file. So let's say df equals pd.read_CSV, and we'll put in data train. And we'll also go ahead and get df test, and we'll call that df test, pd.read_CSV, and put in the test data set. Okay. Now, let's go ahead and take a look at it. We'll just look at the training set, data train, df.head. Okay, so get it up there, change your title header. I'm going to call mine MNIST intro. Okay, so what you see here are a lot of rows of data. And do note that this first row doesn't make sense compared to the other. That's because there shouldn't be a header here. So what you want to do is actually put in header equals none. Okay, header equals none, and then try it again. And now when you look at it, you can see it's simply numbered in order. Like, what's numbered in order? Well, it's these rows of data, and what these are supposed to represent in visual images are pixels. So if you look at the first row, okay, you've got this 0 here as the index, but it's 6 is given as the first number. And so if you follow all these pixels out, there's 784 of them, the representation is a visual 6. The second row, the representation is a visual 5, and so on. Now, we're not actually seeing the pixels here, so we can try to get a look like at a whole row. So how about something like this? Let's look at for I in what? Okay, we're going to do df.ilock, and to look at the first row, we can take the 0th row, and we want all the columns. So we'll go ahead and keep this, say the 6. And then what are we doing with this array? We're going to actually print it out. Okay. And so we're going to print I, and then I think you can do this end and show a string, and that way I think it'll look a little better. It'll give space between the characters. Let's see what this looks like, if it does what I'm hoping it'll do. Yes, so you see the row printed out, and it's all these zeros. And if we keep scrolling, there we go. We're going to start to see pixel values. Okay, these are grayscale. These are the values of various pixels in various places. And the reason why they are gapped is because this is, in effect, a one-dimensional representation of a two-dimensional object. And this is sort of like the idea, in some ways, behind machine learning of unstructured data, which is that, okay, we have an image, let's convert it to a bunch of numbers, and this would be the classical way of looking at it, which is it's just a string of a bunch of numbers. but they are in fact disjointed. And so I think it's natural to sort of want to see it as is, like the two-dimensional shape. Colab's not going to have good output for this to look at just the value of the pixels. But let's go back up to the data, and we can see there's 784 columns, right? So if this is a 2 by 2, okay, what might that be? Well, first of all, the shape gives you the whole thing. I guess we haven't specified our X yet. DF shape. And if we look at it, we can see there's 20,000 rows, so 20,000 different numbers. This is the small data set. And it says 785 columns, but that first column is actually the value of the number itself. Okay? So the idea is this. You can reshape, say, this row into a 2 by 2, and that's what it originally is. You can do that using NumPy. So if you import NumPy as in P, and then, how can you reshape it? We may need to convert this into a NumPy array first, okay? Because it's reshaping as a technique of NumPy arrays. So let's just look at how we might do that. So this is a row of data, right? Now, technically, we don't want the 6 because we want to try to turn this into a square. So what I'm going to do is change this to a 1. So we start with the first index. And then we're going to try this. We'll call this row of the data. And np.array, and try to convert it as such. Okay? Let's see if it in fact works, and it does. Okay, but the point of doing this is now that the advantage is you can do row data.reshape. Okay? So the row should be 784 characters, and how are we going to reshape this thing? Well, let's get it in here. It's df shape. Well, okay, let's just do 784. So it's 784 to the 0.5, because if you square root 784, you'll find the square. I think the images are actually originally squares here. And so it is 28. And so since 28 times 28 is 784, you can reshape it to 28 by 28. You can't just do that to any numbers, right? Like if you try, let me just show you, if you tried like, I want 20 by 28, does not work. Oh, it did say array of size 785, which, let me check that. Oh, because we don't want all the columns. We want starting with the first column. And by the way, I took the first row, different row, so this is not going to be a 6. It's going to be a 5. Okay, so rerun this. That's good. And the point here is you need 28 by 28. As long as the numbers multiply together to give you 784, it will in fact work. Okay, and you can see it shows sort of like a visual representation of it, although it is kind of jumbled because it's just, I was messing with this before and it's a little hard to do. You can try on your own to kind of get it to show the full row in Colab. Okay, not easy, with outputs streaming across the screen. You can see if I go smaller here, did that make a difference? I'm not sure. You could try one more maybe. You can hit these command minuses and pluses to make them larger and smaller. So it's showing, I don't think it's changing it, no. Okay, so this is not the point, okay? If it was all smoothed out, this would represent a 5, okay? I'm just showing you how you can really kind of see the numbers of the pixels and how you can go from, a row of data that is representative of an image as it is stored here in Colab to the actual 2D representation using this reshape, okay? Last thing we will do though is we can show the actual image. So there is another way to do it using matplotlib. And so here, if we want to actually see the 5 as it's supposed to be, we can import, let me make this a little larger for you all. We can import matplotlib.pyplot as plt. Okay. And then what do we want here? There's actually something called image show. So we can do plt.imageShow. And then what are we showing? Well, we have this, I think it's called random row. And we can go ahead and make it gray because that's what it originally is. Otherwise it adds some colors that aren't actually there. Is it called random row? They've called it something different. Row data, sorry. See, the underline is helpful there, suggesting, okay, this is not something that we know. Row data, the CMap is going to be gray. And we can also turn the axis off because it just looks a little better. We're not worried about the coordinates of this. And then you can show it. So let's see if this, in fact, gives us the image itself. All right. Got an error here. Invalid shape. Oh, it did. I didn't save it. So let's save it. Okay, so I did the reshape without saving it. So we could see the visual. So we'll come in here and save it. We can just call it the same thing. Row data equals row data.reshape. Try again. And there you see the actual 5, the real pixelated version as it was originally stored in the MNIST dataset.